Audio Jungle. Audio Jungle. Audio Jungle. Audio. Audio Jungle.
Let's get to the next topic, talking about work. In physics, work means something different from our daily usage of work. Because when we say I go to work, maybe I would go to an office, I go to a school, or go to a factory to go to work. But in physics, work has a different meaning. Work is something that is done on an object if the object is moved through some displacement while force is applied to it. So this is defined by an equation called work is equal to force multiplied by delta x, or the displacement, the change in displacement. So we would say that a work is done in physics if you use force to move something from one point to another. Take note that we are talking about displacement. So the F in the equation that we have a while ago is the force, the magnitude of the force. Delta x is the change in displacement, the magnitude of the displacement. And of course, W is the work. Please note that F and delta x are in the same direction. The unit of work is joule. Take note, it's joule, 1 joule, which is also equivalent to Newton meter. So if we transform the units, we would have kilogram multiplied by meter squared divided by second squared. So we have kilogram meter squared per second squared. So if we compare the physics definition of work and our everyday understanding of it, we can see that it has some tiring tasks may not constitute work if we look at it from the physics point of view. For example, a student doing exercise by pressing on a wall doesn't do any work, although that is a tiring task because there is no displacement. Because there is no displacement, then there is no work. Because remember, the equation for the work is equal to the force multiplied by the change in displacement. But then pushing on a wall doesn't change your displacement. Thus, in physics, no work is done. Work is a scalar quantity. Therefore, direction is not associated with it. However, when the force exerted on the object is not in the same direction as the displacement, the force on the object is split into the x and y components. When this is the case, only the force on the direction parallel to the displacement does work on the object. So consider the following figure. A constant force F is exerted at an angle theta along the direction of the displacement. Hence, the equation for work is given by W is equal to F cosine theta delta x. In order to have work, there must be at least two objects. In order to have work, there must be at least two objects. Taking a nail, for example, the nail cannot do work on itself. However, a hammer does work on the nail when it drives the nail into a board. Since several external forces can be exerted on an object in motion, the total work done on the object to reach the magnitude of displacement is the sum of the amount of work done by each force. So what we're seeing right now is that work requires two objects so that we could be able to perform work. Like for example, for me to push a box, it's me and the box. Like for example, the nail and the hammer. So you need the hammer to push the nail. Likewise, for us to say that a tow truck pulls a car, there's work done because a tow truck is carrying the car away by pulling it. So here we have learned that work in physics has some things that are not very similar to the work that we are very accustomed to. So I hope that you learned something and see you in the next topic.